Review day. You should take out something to write with, something to write on, a calculator so you can participate. Yeah, I really kind of need you to participate. I want you to do well.
I can do this test in 40 minutes.
The test on Tuesday? I don't know how good at calculus are you. I can do it in 40 minutes.
I have 630.
I can probably do it in 15 minutes.
I will do a partner house with you. And it's really great.
What are you going to contribute? Write down what I tell you to.
Hey, I know some things. Just like paper.
Oh. Every test of Nora's is a partner test with me. Come on, that was a good one, Nora.
I look, you asked a lot of questions.
You do. It's okay. I typically don't turn you guys away.
Oh, Mr. Click, you're so funny.
I try.
Are you gonna miss us?
Every day. What's that?
I said until he doesn't have to see us anymore.
All right.
No, Mr. Click likes us.
So I just grabbed some questions from the books review that I thought would be good representative stuff. So I don't know. I have like 6 or 7 or 8. I don't even remember how many I picked anymore. I don't think we'll finish them all. That's fine. Whatever. I just grabbed some that I thought would be good ones. All right. So number 2, it says, let f of x equal x to the 5th. Write down f prime of x. Who can tell me what f prime of x is? 5x to the 4th is correct. It says then that the point 232 lies on the graph of f.
You want to cheat us?
It says find the gradient of the tangent to the graph of y equals f of x at point P. What do we need to do to get that?
Flip it up. The slope. The points.
Hey, Sam, I have a question. Why are you still? Why are you? Why is all your stuff in all 3 seats?
You just spreading out,
Very
man.
beautiful fashion.
Yeah.
Okay.
Mr. Butoric does the same thing in the lunchroom. Yeah, it just spreads out. All right, what do we have to do? We were looking for the slope, aka gradient of the tangent. How do I find that?
Put the x value of the point you're looking for in your derivative.
Yeah,
Just as your slope.
that's right. We're just going to plug 2 into f prime. That's going to give us, I think, 80. Great. And then C says, find the equation of the normal to the graph of P. Give your answer in the form yada, 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 where the things are integers. Yeah, what does normal mean?
Perpendicular.
That's exactly right. So my normal slope will be the negative reciprocal. Well done. The point we know is 232, right? So to write the equation for this line, am I going to write it immediately in this form?
Absolutely not.
No, what am I going to do? Or point slope is what I'm going to use. So y minus y1 equals m times x minus x1. And then I'm going to deal with integers first. So I'm just going to multiply both sides by negative 80. 2560, I think. Oops, plus. And then I'll just subtract x from both sides and add 2 to both sides, and I am dunzos.
Is this basically what the test is going to be on? What's going to be?
I mean, the test is basically the quiz plus optimization. So, yeah, some word problems. So I got some examples in here. I'm just kind of like, I picked some stuff that looked challenging or appropriate or not necessarily like uber repetitive. All right, on to the next question then. Consider the curve. Y equals yada, yada, yada. Write down dy dx. What does dy dx mean? That just means do the derivative. So what is the derivative here for...
2x squared.
Not 2x squared. 3x squared
Oh, yeah, yes.
plus 2kx. That's correct. The next thing says the curve has a local minimum at the point where x is equal to 3. What does this mean? So the derivative is 0 when x is equal to 3. Is the same thing true at a maximum? Yes.
It's only going to be 3. I'm going to go wash my hands if that's okay.
It's going to equal 0.
Yeah, but
The 3 is because that's where the minimum is at, right? So what are we going to do to find the value of k? Well, I'm just going to take my derivative, plug in 3, and set it equal to 0. Because I know the derivative is equal to 0 when x is 3.
Can you explain that like one more time why it's equal to? Is that just the way it is?
So if you think about this guy's a maximum, right? Or this guy's a minimum. If I draw the line tangent to that, it's going to be a horizontal line, right?
oh,
What's the slope of the horizontal line? 0.
Okay.
So the derivative at any extrema, whether it's a max or a min, is going to be 0. Is that explanation sufficient? Good. So I just solved that equation and got negative 9/2. Find the value of y at this local minimum. How do I find a value for y? Yup. So I'm just going to be plugging what into here? I'm plugging in 3 and negative 9/2 for k. So that's 27 minus 81/2. So that's 54/2 minus 81/2, negative 27/2, I think. If I did the arithmetic appropriately. If you have your calculator, you could double check me.
alright. Okay, I have a question that doesn't involve this, but can you answer it?
I hope so.
So,
Purple. Purple.
No.
It's my favorite color.
Oh, I'm so glad. My favorite color is blue.
Fish.
No.
Favorite animal.
No.
Oh.
Really? Abstract. What is abstract? Like, what am I explaining?
So you're giving a 1-paragraph summary of what happens in your paper.
Yeah.
Typically 1 to 2 paragraphs, probably not any more than
We
that.
have to have it. Really? Yeah. She told me that when I asked her. Thank you, Mr. Cool. Thank you, sir.
So like, yeah. So just in general, let me
Did she say Did she say anything? She just said no one. All she told me was no one turned it in, and abstract you need to have. Okay.
You're right about the negative 20 stuff, yeah.
Oh, good. So, like, here's a mathematics paper,
Oh,
and that's what the abstract looks like. It's just a paragraph.
so it's just a paragraph, and then all I have to do is explain why I did. Why
So
I
it says,
did that.
let's read this. It says VLSI, don't care what it is, design is probably the most fascinating application area of combinatorial optimization. Virtually all classical combinatorial optimization problems and many new ones occur naturally as subtasks. Due to the rapid technological development and major theoretical advances in the mathematics of VSLI design has changed significantly over the past 10 to 20 years, this survey paper gives an up-to-date account on the key terms or key problems in layout and time enclosure. It also presents the main mathematical ideas used in a set of algorithms called bond tools, which are used to design many of the most complex integrated circuits in industry. So it's just like a summary of what you're about to read.
Yeah, she was saying to explain like what the definition of caffeine is. What's coffee?
So,
my thing is extracting caffeine from coffee.
yeah, I mean, you could give like a little overview as to like why you'd care about this and what's about to happen when you read the paper or what you'd expect to see in the paper.
Okay, thank you.
But that's I think just an example of an abstract is usually enough to give an idea of like, oh, okay, that's what it's supposed to sound like.
Are the words before the Star Wars movie, would that be considered an abstract?
That's like the epilogue. That's like what's happened already in the world. Or prologue, I should say, not epilogue. Epilogue's at the end, prologue's in the beginning. So like if you pick up a novel, like the back cover of the novel is sometimes like kind of like an abstract, or it kind of tells you what you're about to be reading about without giving away the whole thing. In your research paper, it's okay to give away the whole thing though. All right. Number 5, it says f of x is given as yada, yada, yada from -5 to 5 and x not equal to 0. Write down the derivative. Who can tell me what the derivative is for this f of x?
My answer is going to be -4 over x. You know why?
Or you could write it as -4x to the -2. You could write it that way too, that's fine. Because I'm going to think about 4 over x as 4 times x to the -1. Right? We're okay there. Use your GDC to write down the coordinates of the local minimum point of f in the given domain. How am I going to do that? Yeah, like I'm literally just going to graph the thing on my calculator and set the window from -5 to 5. Now I might have to monkey with the y's to make sure that I can see it. So I could do it this way. And then I don't know what to expect here. I'll just write down -10 to 10. So what's the bummer?
It's too hard.
Yeah, I can't see all the way down there. Oops. So I guess I got to change my y min. It looks like it maybe goes down there really far.
Just like Z6.
Yeah, you could try that. I don't know. It's going to mess with the x or the x range though. I prefer having the control. So you can do it this way. This is fine what we're doing. You know. Oh, I see what's going on. That's so dumb. Anyways, so this is like kind of a hassle, right? Trying to do it this way. What's the other way you could do it?
With the math.
Well, that's I'd be looking to find using the calculator to find the min and the max. But what if I do this instead? What if instead of graphing f of x, I graph the derivative?
Use the for
And then I just look for the 0 and where it changes from other way around for minimum, negative to positive. So I just graph the derivative. So this one is a maximum because it's changing from positive above the x-axis to negative below the x-axis. But this one over here is the minimum because it's changing from negative below the x-axis to positive above the x-axis. So all I need to do is find that 0. And look how much easier it is because you know where the y value is. You're just looking at it for 0. You're just looking for x-intercepts. So 1.08. And then the y I can just now plug in. And to do that on my calculator, I'm just going to do like y1 of, because that's where I typed the original function, that 1.08. So 9.92. What do you guys think? I'm not going to do part C because it's just the same thing, except now you're finding the maximum. You guys happy?
So essentially, the easiest way is to just grab the derivative, put the derivative.
That's what I do. Yeah, and whether you put the derivative that you find by hand in, or the way that I set it up on the calculator is I just typed the original in and then asked it to find the to graph the derivative of the original. So I'm not even going to risk the possibility that I screwed up finding the derivative. You know, as long as I type in the function the right way, you know, there's no possible error there. So I like that. All right, on to number 4. Here's a fun optimization problem. A lobster trap is made in the shape of a half a cylinder. It is constructed from a steel frame with netting pulled tightly around it. The steel frame consists of a rectangular base, 2 semicircular ends, and further support rods as shown in the diagram. The circular ends each have radius r and the support rods each have length L. Let T be the total length of steel used in the frame of the lobster trap. Part A says, write down an equation for T in terms of R, L, and pi. So I'm just going to start counting things up. So I have 1 L there. There's 2 L's, 3 L's, 4 L's. Everybody happy with that? I have 2R for that chunk, and then another 2R for that chunk, so that's 4R total. Everybody's good with there? Then I have half of a circumference for a circle, plus another half of a circumference of a circle. So that's 2 half circumferences. So the 2 and the half cancel each other out. So there's my equation. What do you guys think there? What's up? Yeah, like add stuff up. I don't know, like you just have to add up the parts in the picture. That's the scary part. Okay. Then it says the volume of the lobster trap is 0.75 cubic meters. It says write down an equation for the volume of the lobster trap in terms of R, L, and pi. So the shape here is half a cylinder, right? So my volume is going to be 1/2 the volume of a cylinder, which is the area of the base, which would be a circle, pi r squared, times the height, right? The height in our situation is this measurement L. And I guess I know the volume is 0.75. So I write it that way, I guess, if I want to. It says show that T is equal to this equation. Okay, this is a super common presentation for IB. They're often going to give you a problem like this where it's going to say show that something is equal to something else, because they know that you're going to need this equation to finish the problem. So they're going to give it to you so you can still be able to do parts D, E, F, etc. Even if you screwed up this part, even if you can't show it, you still should use it. So this is their way of making sure that, like, I didn't give you a problem where if you get one part wrong, you're going to get like -10 on it. Yeah, well, they tried very hard to do this. So what I'm going to do is I'm going to start with my equation for T that I have. And if I look at this part of equation T, and I look at this part, that's really the same thing, right? We've just factored off a greatest common factor of R. What I still need to do, though, is somehow this 4L piece needs to turn into this now. So I need a second equation that has R and L in it so that I can make a substitution into here. Where is that second equation going to come from? That's why they asked us to write it down an equation for the volume preceding this. So to get the L by itself, I'll multiply both sides by 2 to get rid of the fraction. And then I'll divide by pi r squared. And then I'll go ahead and substitute this in. And when I multiply 4 times 1.5, that gives me the 6. And I'm super excited because that's exactly what we needed. So the answer for this question for part C is all of our work, right? Because the question says show, the answer is work. What do you guys think? Is this okay? Notice how they're like walking you through this. Like, write down this equation, write down this equation, show that when you combine them together, you get this equation. Now in part D, it's going to say take the derivative of that equation we just gave you. So even if you can't do parts A, B, and C, can you do D? Of course, because you have the function for T, right? So what do I get when I take the derivative of T? I get 2 pi plus 4, and then minus 12 over pi r to the third. Or again, you could think about this as 6 over pi r to the negative 2, and then differentiate. Everybody's okay? It next says the lobster trap is designed so that the length of steel used in its frame is minimum. Show that the value of r for which t is minimum is 0.71 meters, correct to 3 significant figures. How would I want to do that? Says show that the minimum for t is 0.719. So the easiest way to do this is you want to do two things. You want to show that dt dr when r is 0.719 is equal to 0. And the second derivative when r is 0.719 is positive. That's the second derivative test that shows you that you have a max or a minimum. So if I just go and I'm just going to do this in my calculator. So again, I'm going to plug in my function for t, I guess, because I think it's going to ask me for the minimum value here in a minute. So what was my equation for t? It was 2 pi plus 4 plus 6, write it that way, 6 over pi r squared, right? Oops, got my x there. So this is going to be, y2 is going to contain my first derivative, right? So y3, I'm going to make my second derivative by just taking the derivative of y2. Right? If I take the derivative of the derivative, that's the second derivative. Everybody's cool? I'm not going to do it by hand because I don't have to. So again, I'm just going to do math, command 8, and derive, and then fill it in just like before, except I'm going to put a y2 there instead of a y1. So now I'm going to do y1 of 0.719. Oh, I'm sorry. That's the function. That's t. I don't care about that. At least not right now. I wanted to do y2. That's the derivative. Excuse me. So that should be about 0. Looks good to me, right? And then y3 is my second derivative. And I'll just do the same thing. And I have a positive value there. So that's enough to show that
second derivative is just the derivative of the derivative.
Yep. You just do the derivative again.
Where do you get 7?
It was given to us in the problem. They said show that that value for r is a local minimum. Whereas the minimizes the value for, or amount of steel or whatever, which that's what we did. You guys happy with that? You could have also done this as a first derivative test, or you could have set the derivative equal to 0, solved it probably with your calculator, and then picked values more, greater, and less than 0.719 and shown that it changes from negative to positive. That would be acceptable also. I think that's a lot more work. This I could do almost entirely with my calculator without having to like graph anything and find any intersections and plug anything extra back in. I just, found it's a little cleaner. But either is appropriate. They're both correct. Everybody cool? They might have even taken, if this was like an IB question, they might have even accepted if you showed the graph at t and then said like you found the minimum with your calculator and you got this value and it matched the 0.719. Might have even taken that. I don't know. So there's that. Calculate the value of L for which t is minimum. So we know that R at about 0.17 time gives t a minimum, right? And we know that L is equal to 1.5 pi r squared. So that'll give us our value for L that makes t minimum. And then G says calculate the minimum value of t. Well, that's just going to be t of 0.179. And I did that accidentally already on my calculator, right? That was the first thing I did. That's that 11.1, I guess, to 3 sig figs. What do you guys think on that? Olivia's frustrated enough to put her head down because she's like, I can't do geometry. I had to count things and add things up. Great googly moogly. All right. We'll continue on. We'll do some more. It says, consider the function. This guy, apparently I missed part of the 3 there. I did look that up, and when I did it earlier today, that is a 3. That half a number there, it's not a 5. I wasn't convinced it was one or the other. 5th hour was convinced it was going to be a 3. They were right. Find f of -2. How do I do that? Yep. So again, the way I would do this is I'm just going to type in it this way. I'm going to have I would ideally have this kind of set up in my calculator already to go with the first derivative and the second derivative already stored in there. Because it just now I can just do if I want to evaluate the derivative at something, I just type in the original and do y2 of whatever the number is. If I need the second derivative, I just do y3 of whatever the number is. And it's all set to go. I just have to remember to update the original. So I love doing that. It makes life so simple. Oops. So we do that, I get 4. B asks us to find f prime of x. What is f prime of x here? I'm just going to reduce, right? Okay. Okay, and we don't need to write the plus 0. It then says the graph of the function f has a local minimum at the point where x is equal to -2. So we know that is true, right? Using your answer to part B, show that there is a second local minimum at x equals 3. So what I would do is I would set this equal to 0. I can take out a greatest common factor of 3x. X squared minus x minus 6 I can factor. And when I set each of these equal to 0, I get x equals 0, x equals 3, and x equals negative 2. I would probably do a first derivative test here. So if I plug in, say, negative 3, I'd have negative times negative times negative. If I plug in negative 1, I'd have negative times positive. If I plug in positive 1, I'd have positive times positive. If I plug in, say, positive 4, I'd have positive times positive. So I can say x equals negative 2. Oh, I should say x equals 3 is a local minimum because it's changing from negative to positive. Well, I picked to do that because I suspected that I was going to need to do something else. Yeah, like here in part E, it says it wants the coordinates for the local maximum. Look, I've already found the x coordinate for that. So if I see there's going to be like more than one thing, oftentimes I'll do a first derivative test because often I'll get like stuff for free for later questions that I don't get with a second derivative test. What? I saw that there was a lot more after it, so I figured like the first derivative test might be more useful. Maybe I was going to ask for like intervals of increasing and decreasing or something, which I get with the first derivative test also. I could have done it as a second derivative test though and just shown that like f prime of 3 is equal to 0 and f double prime of 3 is positive. That would be appropriate. Nothing wrong with that. So D I just don't want to do because you just can type in your calculator and hit graph. Like, what do I need to, whatever. E, I know that x equals 0 is the maximum. I'm getting that. So to get the y coordinate for that, I just do f of 0, which I can see is 20. Because everything has an x in it, other than the 20.
Oh.
Right, I'm just plugging 0 in, so it's 0 times 0, 0 plus 0 plus 0 plus 0 plus 20. You're like, whoa, that was fast. Yeah, the 0 made it really easy. And then it says that let t be the tangent to the graph of the function at the point 2, negative 12. Find the gradient of t. So I just need to do the derivative at 2. So that's going to be 24 minus 12 minus 36, which is negative 24. Feel okay? And then we have one more part to this problem. It's like the never-ending problem. It says the line L passes through the point 2, negative 12 and is perpendicular to t at L. L has the equation x plus by plus c is equal to 0, where b and c are integers. Find the gradient for L. What's the key there? Well, it's perpendicular, right? So it's just going to be the reciprocal of the tangent, which we found in the previous part. So here I just need to write this equation. So I'll start with like a point slope equation. I'll multiply both sides by 24. Oops. And then I'll move everything onto one side, but I have to be careful. Notice the x is positive here. So I'm going to move everything onto that side to make sure the x is positive. So b is negative 24 and c is negative 290. What do you guys think there? You feel good on the really abstract ones. The specific stuff is where you're like, I hate this. I don't want to be a lobster fisherman. I mean, there's nothing wrong with fishing for lobsters. I'm going to skip this next one. It's like the same problem. Do I want to do this? This feels like the same problem again. Let's skip it. You guys okay with that? Well, I don't know. Should we do it? Let's do a little bit of it. We'll skip at some point. We'll just get sick of doing this. And there's so many parts, H parts. Ugh. All right. What's the vertical asymptote for g of x? You should be able to look at that and tell me inside of 10 seconds. It is 0. Very good. How'd you get that, Jack? Yeah, 0 denominator makes a vertical asymptote. That's all you needed. What else could have you done if you didn't remember that algebraically? Graphed it on your calculator and looked at the picture, right? What? Yeah, give you 0 denominators are where your vertical asymptotes are. All right, what's the derivative of g? Yeah, that's fine. You can write it that way. No big deal. C says then the line T is tangent to the graph at the point where x is equal to 1. The gradient of T is 3. Show that B is equal to 5. So it tells you that the tangent, when the derivative is, at x equals 1 is 3. That tells you that 3 is equal to, g prime of 1, right? So 3 is equal to b minus 2x to the negative 3. So b is 5. Is everybody okay with what I did there? Because it told me that the slope is 3 when x is 1. That's what that sentence above says. Find the equation for t. Okay, I guess. So my slope I know is 3. It was given to me. My point is 1 comma something. How am I going to get that something? Plug it back into here. So 5 minus 3 plus 1. That's 3. So y minus 3 equals 3 times x minus 1. That's an equation for t. It doesn't tell me it has to be in a specific form. I am not worrying about it. Part E says use your GDC to find the coordinates of the point where the graph of g of x intersects the x-axis. All I'm doing is plugging b in for 5 and then graphing on my calculator and just doing the 0 command, right? I don't have to do that for you guys, right? You're good with me just kind of talking through what I would do? Okay. F says sketch the graph. I'm just going to graph it on my calculator and use the window that they gave me and write down the point that I found in the previous problem where it crosses the x-axis. Everybody's okay with that? Like, it doesn't have to be any more complicated than that. Use your GDC to find the coordinates of the local minimum, and then find the intervals in which they were increasing in the domain. So because I have this question, I would do a first derivative test for that one because I'm going to get the answer to where it's increasing for free by doing the first derivative test instead of a second derivative test. So I'm just going to set the derivative equal to 0. So, probably graph, and to solve that, I'd graph the derivative in my calculator and find the x-intercepts. And then just look at the graph and see where it's above and below the x-axis to draw my sign diagram. And that'll give me the answers for both G and H. Is that enough for you guys to just kind of talk through what I would do? We've done this a couple of times now.
Yeah.
If it's not, that's fine. But I want to get to this last one because it's another optimization problem. And it's a hard one because of the wording. Like, you really have to think about what's going on here. So, no geometry, Olivia, so you should be excited there. A patient is given a hormone injection and the concentration of the hormone in their bloodstream is monitored. The rate of change of the bloodstream hormone concentration is given by dc/dt equals yada, 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 where dc/dt is in nanograms per milliliter per minute, and t is the number of minutes since the injection was given. Find the time at which the hormone concentration is increasing the fastest and the rate of increase at this point. So what is it asking me to find in part A? So it's asking for the maximum in dc/dt. dc/dt is describing the rate, and we're interested where it's increasing the fastest. That's the max for the rate, right? So all I'm going to do is take the derivative of dc/dt, set it equal to 0, and look for the maximum, right? In fact, I probably don't even need to do much on my calculator here. So on my calculator, I'm going to type in dc/dt into y1. think I have the decimal point in there. I have like a smudge on my computer screen. I can't tell. Or just my eyes are going. I used to have such incredible vision. Getting old stinks, guys. All right, so what I'm going to do is I'm going to, if I'm looking for the maximum for this, I'm looking for where the second derivative then is equal to 0. So I'm going to solve there. And then this was for, well, let's think about it. X is time, so the minimum is 0. I don't know what the maximum is going to be. I'm just going to dump it out to like 100. And probably negative 10 to 10 is fine. So I'm just going to hit graph now. Okay, so I notice right here, that's going to be my maximum, right? That x-intercept where it's changed from positive to negative. Looks like I am getting a second x-intercept here, but that's going to be the minimum where it's changing from negative to positive. Everybody's okay? So I'm going to start just by finding my those two zeros so I can draw my sign diagram. Ooh. So 3.94. And the other one is at, I already did it, so I know it's 88.8. So I'm just going to kind of draw a sign diagram here, 0, 3.94. And it says, and it wants the rate of increase. So I need to then take dc dt and plug in 3.94 to that. So I'll do y1 of 3.94. I did y1 because that's where I put my dc dt in. So that's 43.2 nanograms per minute, or per milliliter per minute. Part B, it says, find the time at which the maximum hormone concentration is present. What is that asking for? No. It's asking us to find the maximum for C. Not dc dt, not the derivative, not the rate of the hormone concentration, the actual hormone concentration. So to do that, we're going to take dc dt, set it equal to 0, and solve that guy. So I'll go back to my calculator. I'm going to turn on y1 now and turn off y2. Hit graph. Again, all I'm looking for is an x-intercept here. Yes. Sure. It's like a hurricane in the Pacific Ocean.
Why did they call it a hurricane?
No. Is it the Indian? They have different names depending on what ocean it's in.
It's the Gold Coast.
Main Beach, Gold Coast?
So that Gold Coast is
Australia.
yeah, so it's probably the Indian Ocean.
See,
So that would be a Pacific Ocean. It's a cyclone in the Pacific. Maybe it's a
Caspian Sea.
maybe it's a typhoon in the Indian Ocean.
It's a South Pacific Ocean.
Yeah, I think Pacific is cyclone.
Well, that's what they call it in China with the typhoon, so maybe it's in north versus south.
Well, China also borders on the Indian Ocean, doesn't it?
No, but like I was in Shanghai.
Oh. Okay. I don't know.
I don't know.
Yeah.
Okay. Oh my god, we have no time left. What are we gonna do?
We have 8 minutes.
I need a word.
Yeah, Olivia's hard at work here.
Yeah.
All right. So that was part B. Part C, it says find the time at which the hormone concentration is decreasing the fastest and the rate of decrease at that point. Good news. We've already done the work in part A, right? Because we just need to now find a minimum for dCdt. So we know that that's happening at t equals 88.8.
So,
And then to find the value, we just plug in 88.8 into dCdt. So that's negative 0.436 nanograms per milliliter per minute. And then lastly, part D says if the bloodstream concentration increases at more than 35 nanograms per milliliter per minute, it can be dangerous for the patient. Find the interval where the patient is at risk. So again, if it's measuring a rate, that's dCdt. And I want to find where that's greater than 35. So I'm going to do that graphically. So I'm going to graph dCdt and 35 and just kind of look for the intersection. I got to beef up my maximum for y though so that I can see it. Okay, so it's happened real quick there. I might have to zoom in a little bit more on my x to get a good picture. So this is my graph of dCdt that it's doing right now for me. There's 35. So I'm going to zoom in a little bit with my x's here. So it looks like everything is happening between, I don't know, I think that's 0 and 20. So I'm going to do that just to make it a little bit easier to see what's going on. Because I need to grab both x-intercepts, right? Or both intersections, I should say. So this is the dCdt, this is the line 35. So the section that we're interested in is this one, where the dCdt is above 35. So I'm going to find the intersection of the two curves, first curve, second curve. Guess. And I have 0.594.
Oh.
And then just find the other one, second trace, intersect, enter, enter. And then my guess has to be down here. That's probably close enough. 12.3. And that's it.
That's that.
That's that.
it's not that bad.
Are you partying this weekend?
Partying this weekend.
Yeah.
Like doing part E of homeworks.
Maybe. Having a homework party?
Part E?
Party.
Oh, part T.
That's a lot of homework. There's a part T.
Yeah. I bet there's one of the homework sections had a part T in there.
Yeah, honestly.